In this video, we shall discuss about solution of system of linear equations using inverse of a matrix. Now, in your class 10, you have already read about solution of linear equations in two variables. Tell me, when a system is consistent? A system is consistent if it has a solution. And a system of linear equations, if it has no solution, we call the system is inconsistent. In your class 10, system of linear equations in two variables, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. It has a solution when a1 by a2 is equal to b1 by b2 equal to c1 by c2 for many solutions, infinitely many solutions, and a1 by a2 is not equal to b1 by b2. This is unique solutions, condition for unique solutions. Now, in these are the two situations when the system of this linear equation are consistent. And inconsistent, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. And these things in your class 10 were derived either graphically or from the cross multiplication method, and that cross multiplication method is nothing but the application of determinants and matrices in solving system of linear equations. Now here we shall discuss how to solve a system of linear equations using matrices, inverse of matrices. If we discuss the equations in three variables, then it will be easier, or we can do the same method for system of linear equations in two variables. Let us consider the system of linear equation in three variables, that is a1x plus b1y plus c1 equal z plus d1 or equal to d1 we write, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. And when d1 and d2, d3 are all 0, that means in the right side the constants are 0, then we call the system is homogeneous. Otherwise, this system is non-homogeneous. Non-homogeneous if any of d1, d2, d3 is non-zero. If all are 0, what is the name of the system? The system is homogeneous. Now, first of all, we shall take the system of non-homogeneous linear equations. Now, I can write this system using matrices as a1 b1 c1, a2 b2 c2, a3 b3 c3 into x, y, z is equal to d1, d2, d3. Obviously, I get this system. This is its matrix design. How? When I multiply these two matrices, you see a1 x plus b1 y plus c1 z. Then a2x, b2y, c2z, a3x, b3y, c3z equal to d1, d2, d3. तो a1x plus b1y plus c1z becomes d1. a2x plus b2y plus c2z become d2 and so on. So we can write this using matrices in this style. Now this matrix is the matrix of coefficients, and this matrix is a column matrix, is the matrix of variables x, y, z. And right side the matrix, it is a column matrix. These are the matrix of the constants d1, d2 and d3. If I write, this is a 3 cross 3 matrix, this is 3 cross 1 and this is 3 cross 1. Now I can write this system using symbols ax equal to b, where a is the matrix of coefficients, x is the matrix of variables, b is the matrix of constants. If in case, if a is invertible, means has inverse. When a will have an inverse or a is invertible, a कब invertible होगा? If determinant of a is not equal to 0, when it is non-singular. Now if determinant of a not 0 or when a is not non-singular or a is invertible, then I can get a inverse. Multiplying a inverse in both sides, I get a inverse x equal to a inverse b, and matrix multiplication is associative. A inverse into a becomes ix equal to a inverse b, so x is a inverse b. Then the matrix x is nothing but the matrix of variables. So in this way I will get the solution. Now for example, before going to examples, let us see the situations, what will happen. Let us analyze. थोड़ा analysis सबसे concept को बेहतर करता है. So your analysis is required. Now for a system of linear equations, what I got? X equal to a inverse b only when a inverse exists. When a inverse exists, that is only when determinant of a is not equal to 0 or matrix A is non-singular. And in this situation we shall get x, y, z are single values or unique values. Therefore in this situation we get unique solution. Now can I write this as how I get A inverse? It is 1 by determinant of A adjoint A into B. Now you see, in the denominator it is determinant of A, numerator adjoint A into B. So if in case determinant of A is equal to 0, then I get two situations. One, adjoint A into B is not equal to 0. Adjoint A into B is equal to 0. In this situation, X is a non-zero divided by 0, non-zero matrix divided by 0 number. That means it is undefined, means no solution. And when adjoint of A into B is 0, then what shall we get? It is in 0 by 0 form. So in this situation it is an indeterminate form, means this formula will not work, but value is there. That is, in this situation there are infinitely many solutions. And this is the situation when in two variables you have read, a system has infinitely many solutions, and that situation was a1 by a2 is equal to b1 by b2 equal to c1 by c2 for two variables. So when this numerator 0 and denominator comes 0, 0 matrix, 0 number, so in this situation the form is indeterminate, means value is there but we are unable to determine, means this formula will not work to find the solution. Solution is there. Now, so what are the consistency conditions for unique solution? Determinant of a non-zero, that is A inverse exists, or matrix is non-singular. But when determinant of A is 0, then we will have to think for two situations. We will have to find adjoint A into B. If it becomes 0, infinitely many solution. I will tell you how to find infinitely many solution. And here, when adjoint of B non-zero, simply there is no solution. If a system has infinitely many solution, then how we shall get it? This formula will not work. So what shall we do? Convert or write a variable, say z equal to k. एक वेरिएबल जगह में k लगा दो. You will get three equations in two variables. X and y. Solve two equations. And get x and y in terms of k. Then put in third equation and check the equation satisfies. Therefore, the solution is x equal to value of x obtained, y equal to value of y obtained, and z equal to k. For different k you will get different solutions. And in our example video I shall tell you, I shall discuss some examples based on this theory.